They shouldn't even exist. Take a seat. Buckle your imagination. We're going on a tour of the weirdest, wildest moons orbiting the Sun's planetary giants. And each one is more jaw-dropping than the last. Let's start with Io, Jupiter's tortured child. The most volcanic body in the entire solar system. Not one volcano, not 10. Over 400 active volcanoes erupting across its surface. Lava fountains taller than Everest. Sulfur plains glowing orange and yellow. What causes this hellscape? Tidal forces. Jupiter pulls on Io like a celestial taffy, squeezing it, kneading it, heating it from the inside. It's not just geology, it's planetary warfare. And then there's Triton, Neptune's largest moon. But here's the kicker, it orbits backward. Retrograde. It's the only large moon in the solar system that does. That means it didn't form around Neptune. It was captured, an interstellar refugee, caught and chained to a gas giant. Its surface covered in nitrogen ice, but it's not still. Geysers of dark material burst from beneath, spraying miles into the sky. A cold moon, a captured moon, a rebelling moon. Next stop, Mimas, Saturn's moon that looks suspiciously like the Death Star. One massive crater, Herschel crater, gives it a distinctly familiar look, but its weirdness goes deeper. Scientists expected an ocean beneath its surface, based on its shape. But there's no sign of one. Or is there? Its wobble hints at something sloshing inside. Could this frozen cue ball be hiding a secret sea? Speaking of oceans, let's talk about Europa. From the outside, smooth, icy, calm, but beneath that icy shell lies a vast liquid ocean, possibly twice the volume of all of Earth's combined. And where there's water, there could be life. But this isn't just water, it's salty, warm, and restless, stirred by tidal heat. Think about it, a world with no sunlight, no air, and yet the potential for alien microbes swimming beneath a frozen sky. But Europa isn't alone. Its cousin Enceladus is a snow-white jewel orbiting Saturn, and it sprays water into space. That's right, massive plumes erupt from its south pole, launching ice and vapor hundreds of kilometers into the void. NASA flew a spacecraft through the spray and found organic molecules, hydrogen, salts, the ingredients for life, on a tiny moon no wider than Arizona. Something is cooking under that ice. Then there's Phobos, Mars' largest moon, but large is generous. It's irregular, potato-shaped. It orbits Mars so fast, just 7 hours, that it rises in the west and sets in the east, and it's spiraling inward. One day, Phobos will get too close, break apart, and form a ring around Mars. This isn't science fiction, it's orbital destiny. Now shift your eyes to Titan, Saturn's heavyweight moon, bigger than Mercury, shrouded in a thick orange atmosphere, not of oxygen, of nitrogen and methane. It rains liquid methane. Rivers of hydrocarbons snake across its surface. Lakes, seas, even waves. But it's minus 290 degrees Fahrenheit. Cold enough to freeze steel. Yet it has weather, seasons, climate. It's the only place in the solar system, besides Earth, known to have standing bodies of liquid. It's alien, but eerily familiar. Let's get weirder. Iapetus, another Saturnian enigma. Half of it is dark as charcoal. The other half is bright as snow. A world split in two. And there's a ridge running along its equator. A mountain range that wraps around the moon like a belt. Where did it come from? No one knows. It looks like a walnut from space. A cosmic oddball with no clear origin story. Now zoom out, way out, to Uranus. Its moon Miranda is a shattered world stitched back together. Cliffs 20 kilometers tall, the tallest in the solar system. Canyons ridges, and terrain that looks like it was cut and pasted together by an indecisive god. It's as if the moon broke apart, and gravity pulled it back into a Frankenstein shape. A patchwork of chaos orbiting a tilted, icy giant. And finally, the wild card, Pan. Not even spherical, it looks like a ravioli, a literal space ravioli. Why? Because it orbits inside Saturn's rings and has scooped up material around its equator. That ring of debris formed a bulge, a ridge, a pasta-shaped moon that clears a gap in the rings like a tiny cosmic Roomba. Small, bizarre, and totally unique. This is just a glimpse, a glance at the celestial zoo that orbits our planets. These moons aren't just rocks. They're laboratories. They're time capsules. Some are active, some are dead. Some could host alien life. Others are ticking time bombs. They challenge everything we thought we knew about what a moon could be. We often look at planets as the rulers of their orbits, the undisputed sovereigns of the solar system. But these moons, they're the revolutionaries. They don't follow the rules, they rewrite them. Some moons have atmospheres thicker than Mercury's, others have none at all, yet still host violent geological activity. Some are ancient and cratered, bearing the scars of billions of years of cosmic history. Others have surfaces so fresh, so smooth, it's as if they were born yesterday. These aren't static worlds. They evolve, they change, they surprise us. Take the way many of them interact with magnetospheres. For example, Ganymede, Jupiter's largest moon, is not only bigger than Mercury, it's the only moon in the solar system with its own magnetic field. A moon with a magnetic shield. That means auroras, glowing curtains of light, dancing across its icy crust, shaped by the giant planet it orbits. A moon with its own space weather. And let's not forget that some of these moons may not be moons forever. Their orbits decay, their surfaces erode. Some are being stripped apart by radiation. Others may one day escape their planets entirely, set adrift into the void as rogue objects, cosmic loners, bearing the chemical fingerprints of the systems they once called home. Some moons act like engines, driving the structure of the ring systems around their planets. Shepherd moons like Prometheus and Pandora don't just orbit Saturn, they sculpt its rings, gravitationally herding ice and dust like sheepdogs of the cosmos. Without these moons, Saturn's iconic rings would be chaos. And in a twist of poetic beauty, some moons are the products of cataclysm, likely formed from violent impacts in the ancient solar system. Pieces of shattered worlds coalescing into new bodies. Every ridge, every groove etched into their surface is a page in the history book of celestial violence. But perhaps the most humbling realization is this. We used to think of moons as passive companions, but now we see them as active players, architects, disruptors, potential cradles of life. Each one offers clues about habitability, chemistry, heat, time, about the very nature of planets themselves. Look close enough, and a moon becomes a mirror, reflecting not just its planet, but our own endless curiosity. What might we find in the methane lakes of Titan? What strange pressures exist beneath Europa's ice? Could microbes be swimming under Enceladus's crust right now, never knowing a star, a sky, or a sun? They don't need to be large to be important. They don't need to glow to be powerful. These moons whisper to us from the edges of our reach. We're not just followers, we're worlds. And somewhere in those icy oceans, fractured terrains, and volcanic pits, lies a secret the cosmos is still keeping. So the next time you gaze at our moon, bathed in pale silver light, remember, it is but one member of a sprawling, unpredictable lunar family. Out there, orbiting giants of gas and ice, are moons that erupt, moons that freeze, moons that whisper with oceans beneath their shells, and rain hydrocarbons from alien skies. They are not background characters in the solar system's story. They are the plot twists. They challenge the definitions of life, habitability, even of what a world truly is. And they remind us, again and again, that the universe is far weirder, wilder, and more imaginative than we ever dared believe. We searched for planets and found miracles hiding in their shadows. Because in the grand symphony of space, even the moons have something to say, and we are finally learning to listen. Imagine stepping onto the soil of a distant planet, a world unlike anything humanity has ever known. Today, we're going to travel beyond the familiar sights of our solar system, plunging deep into the realm of alien worlds, extraordinary planets where reality itself seems to blur with imagination. Buckle up, because we're counting down the top 10 planets beyond imagination, alien worlds that defy logic, challenge our scientific understanding, and spark awe and curiosity within us all. First stop, HD 189733b. Forget the serene blue skies of Earth. This exoplanet's cobalt blue atmosphere isn't a tranquil invitation, it's a stormy nightmare. Winds here roar up to 5,400 miles per hour, 7 times the speed of sound, whipping silicate particles sideways. Translation: it rains molten glass. Imagine standing beneath clouds that shatter into shards of glass, slicing through the turbulent air. This isn't just extreme weather, it's alien hostility at its finest. Then there's Kepler-16b, the real-life equivalent of Star Wars Tatooine. Here, every sunset is doubly spectacular. Literally, orbiting 2 suns, this world experiences 2 shadows cast at once, 2 sets of sunrises and sunsets every day. Imagine standing on its surface, your shadow duplicated, your senses tricked into perpetual astonishment. The sky never stays the same color for long, constantly shifting between warm orange hues and cold purple twilight. If you prefer extremes, meet Gliese 436b. It defies the laws of chemistry, with a surface composed of hot ice. Yes, you heard that right, ice that remains solid, despite scorching surface temperatures exceeding 800 degrees Fahrenheit. Pressures and exotic chemistry lock water into a crystalline form, blazing yet frozen. A paradoxical world that mocks our earthly experience. Next up is WASP-12b, the doomed planet spiraling toward oblivion. Orbiting dangerously close to its star, this gas giant has begun to stretch and distort, becoming football-shaped under gravitational torture. The planet's days are numbered. Within millions of years, its star will rip it apart entirely. Until then, it remains a molten, egg-shaped testament to cosmic destruction in action. Venturing farther, we encounter 55 Cancri E, a dazzling planet made almost entirely of diamond. Imagine a world whose core sparkles under intense heat, where carbon transforms into a vast, glowing gemstone. This planet could redefine luxury itself, a diamond twice the size of Earth. But don't be tempted. Temperatures reaching 3,900 degrees Fahrenheit make this jewel anything but inviting. On TRAS-2b, darkness reigns supreme, reflecting less than 1% of the starlight hitting its surface. This planet is the blackest ever discovered. It's a place of eternal midnight, absorbing nearly all the light that touches it. Its atmosphere boils violently under scorching temperatures, a haunting world of shadows and perpetual gloom. Truly a cosmic abyss. Gliese 581c introduces us to another paradox, the potential oasis turned nightmare. Located in the so-called habitable zone of its star, scientists once hoped it could harbor life. But closer inspection revealed a world of extremes, tidally locked, one side forever baking under relentless sunlight, the other eternally frozen in darkness. Life here would teeter on an unforgiving edge, trapped in a delicate balance between scorching heat and absolute zero. Now let's journey to HD 131399AB, an exotic planet with 3 suns blazing in the sky. The gravitational dance between these 3 stellar bodies creates an endless cycle of days and nights, lasting hundreds of Earth years each. Imagine seasons lasting lifetimes, temperatures fluctuating wildly, and skies painted by ever-changing stellar configurations. Truly, a world straight from science fiction. Stepping into the twilight zone of Kepler 438b, we find a potentially Earth-like planet, but with a catch. Orbiting within its star's habitable zone, it faces violent outbursts of stellar radiation hundreds of times stronger than Earth's fiercest solar storms. This relentless radiation bathes the planet constantly, stripping away its atmosphere, bombarding the surface with destructive flares. Any life here would need to be unimaginably resilient, surviving at the razor-thin boundary of existence. Finally, we arrive at J1407b, an immense gas giant, ringed by a colossal system of dust and debris, dwarfing Saturn's majestic rings. These rings stretch out hundreds of millions of kilometers, dense enough to block out its star's light completely for weeks. Imagine standing beneath this alien sky, watching as a cosmic ring system eclipses the heavens, transforming day into surreal darkness, a spectacle unmatched anywhere else in the universe. Each of these planets challenges what we think we know about worlds beyond our solar system. They aren't just distant balls of rock and gas. They're cosmic enigmas, reshaping our understanding of the universe. Every discovery pushes humanity's imagination further, compelling us to keep looking upward, keep questioning, keep wondering. These planets remind us that out there, in the vast cosmic ocean, anything is possible. Our cosmic journey continues, plunging us deeper into the universe's boundless catalogue of peculiar planets, each stranger, more mesmerizing and utterly different than any we've encountered before. Picture GJ1214b, a planet enveloped entirely in ocean, a boundless watery world with no known landmass. Here, there are no continents to anchor life as we know it, only an endless, steaming sea, stretching infinitely beneath a dense atmosphere thick with clouds. Beneath the immense pressure and heat, the oceans may exist in exotic forms, possibly becoming something like a global hot water bath of unimaginable scale. Could this strange, aquatic environment harbor life forms utterly alien to our understanding? Imagine swimming in a planetary ocean deeper than Earth's deepest trenches, beneath perpetual twilight, an alien abyss of secrets. Then there's HATP7b, a planet where storms defy imagination. On its searing surface, fierce winds rush at speeds that could melt rocks, swirling luminous sapphire clouds laden with vaporized minerals. Imagine gazing upwards to see metallic raindrops hurtling downwards, liquid rubies and sapphires crystallizing into shimmering gems as they plummet through the fiery atmosphere. It's as if nature itself decided to paint a surrealist masterpiece using cosmic materials. PSRB 1620-26b, affectionately known as Methuselah, takes planetary strangeness to another level. Located in a globular cluster far older than our solar system, Methuselah is the oldest known planet, an elder world that formed approximately 13 billion years ago. not long after the universe itself burst into existence. Imagine the wonders and secrets this ancient planet has witnessed across cosmic history. A silent observer older than many of the stars that fill our skies. Venturing further into the exotic, consider WASP-17b. This enormous world orbits in reverse direction against the rotation of its host star. It's an immense gas giant, puffed up and extremely low density, like cosmic cotton candy orbiting defiantly backwards. Such reverse orbits challenge everything we understand about planetary formation, hinting at a violent past, perhaps a chaotic collision or gravitational tug-of-war in the early epochs of its star system. Beyond these extremes, Ogil 2005b LG 390LB emerges as one of the coldest, loneliest planets discovered yet. Its surface temperature hovers around -364 degrees Fahrenheit, far colder than Pluto. Orbiting distantly from a faint, dim star, it endures endless, frigid solitude, its rocky surface likely frozen in eternal twilight. Life here would be radically different, if possible at all, perhaps surviving in pockets of hidden warmth deep beneath the frozen crust. Not to be outdone, planet Korot 7b provides a vision straight from Dante's Inferno, a lava world, a scorched planet where rivers of molten rock surge beneath a blistering sky. With surface temperatures hot enough to vaporize stone, the daylight side of Korot 7b boils away rock into clouds of vapor, which then condense and rain down as pebbles and stones. Imagine volcanic rains battering the landscape, redefining the very concept of weather. Wandering further, we encounter GJ504b, a planet unlike any conventional world we know. It's a radiant sphere of magenta-hued clouds, glowing with a surreal pinkish color visible from afar. Its extraordinary color stems from intense heat radiating from its core, combined with clouds of mysterious compounds suspended in its atmosphere. Picture looking out onto this cosmic cotton candy giant, floating serenely in the darkness, a testament to the endless creativity of the universe. Then there's Kepler 10c, famously dubbed a mega-Earth, an enormous rocky planet nearly 3 times the size of our world. Scientists originally thought planets of such magnitude had to be gas giants, but Kepler 10c shatters that assumption. It's solid, heavy, dense, defying our previous planetary theories. Standing on its immense surface, gravity would press down with crushing force, making even walking a monumental effort. And what about HD 106906b? This rogue-like planet orbits at a breathtaking distance from its star, over 60 billion miles away. Such a distant orbit seems impossible, hinting that this world was flung outward by some gravitational upheaval, now drifting on the edge of its star system. Imagine the haunting sight: a dim sun barely brighter than a distant star, illuminating this lonely planet's dark sky. Truly a world on the brink of exile. Lastly, envision HR5183b, a planet with one of the most eccentric orbits known. Its journey around its star isn't a gentle ellipse, it's a dramatic, stretched path, plunging dangerously close to its sun and then drifting impossibly far away into freezing darkness. Seasons here would be chaotic. Brief, intense heat waves, followed by centuries of icy silence, an eternal seesaw between extremes. These astonishing worlds, scattered throughout our cosmic neighborhood, whisper to us of possibilities we can scarcely imagine. Look around. Everything you see, every star, every planet, Every galaxy is part of a vast cosmic symphony. But today, we're stepping beyond that familiar stage and into the uncharted fringes of reality itself. Welcome, fellow cosmic travelers, to the edge of the believable, where science itself blurs into the surreal. Let's dive headfirst into anomalies so strange, so astonishing. They challenge the very foundations of our understanding of the universe. Imagine first something known as the Bootes Void, an eerie cosmic emptiness so vast it defies logic. Picture this: a region of space nearly 330 million light-years across. That's right, 330 million. Within this incomprehensibly huge void, there are just a handful of galaxies scattered like tiny islands, lost in an endless ocean of nothingness. To give you perspective, if our Milky Way sat at the center of the Bootes Void, it would have taken centuries for our telescopes to spot even one neighboring galaxy. Scientists remain baffled. What cosmic event created this vast emptiness? What powerful forces were at play? These questions still echo through the halls of astrophysics labs worldwide. Now let's swing our telescope toward an equally perplexing mystery: fast radio bursts, or FRBS. Imagine signals arriving from distant galaxies, intense bursts of radio waves lasting mere milliseconds. Blink and you'd miss them. But the energy released is equal to millions of stars exploding simultaneously. Where do these signals originate? Aliens sending us messages, stellar collisions, or perhaps something stranger still, like neutron stars screaming their final cosmic breaths? Astronomers are on the edge of their seats, racing to decode these enigmatic pulses from across the cosmos. From pulsating signals, let's turn to hypervelocity stars, rogue suns hurled across the galaxy at mind-boggling speeds. Imagine a star, millions of times the mass of Earth, traveling at millions of miles per hour, so fast it can escape the gravity of our Milky Way itself. What propels these stellar nomads to such extremes? Usually, it's a close encounter with a supermassive black hole, violently flinging them outward in a gravitational slingshot maneuver. Think about it. Right now, somewhere out there, entire stars are hurtling through the darkness of space, doomed to wander alone until their fiery deaths. Speaking of black holes, let's talk about perhaps the strangest anomaly of them all: white holes. Theoretically predicted by Einstein's equations, these bizarre objects are essentially the opposite of black holes, spewing out matter and energy rather than sucking them in. Imagine a cosmic fountain pouring matter into our universe from elsewhere. Could it be a gateway to another dimension, another universe? While we've yet to detect one conclusively, physicists eagerly chase the ghostly evidence, hopeful that one day white holes might unveil deeper truths hidden beyond our wildest imaginations. Now hold on to your seats, because we're headed to the coldest spot in space. We're talking about the cold spot in the cosmic microwave background radiation, a colossal region, roughly 1 billion light-years wide, that's mysteriously colder than the rest of the observable universe. Scientists are puzzled. What could cause such a vast temperature difference on cosmic scales? Is it evidence of another universe brushing against ours, creating an immense cosmic bruise? Or perhaps it's just a fluke, a statistical anomaly challenging our most sacred cosmological theories. One thing's for sure: this frigid mystery chills scientists to their bones. And what about the bizarre star, known simply as Tabby's star? Imagine watching a star suddenly dimming dramatically without any clear reason. Is it a swarm of comets passing by, cosmic dust clouds, or maybe, just maybe, an advanced alien civilization building something colossal, like a Dyson sphere, around their sun. Astronomers scratch their heads, telescopes glued to the sky, waiting for the next drop in brightness. The mystery deepens with every observation, pushing the imagination and science to their absolute limits. But if that wasn't enough, brace yourself for gravitational anomalies, strange places where gravity doesn't behave quite as expected. Imagine regions in space where matter seems to be influenced by unseen forces, bending light in ways that defy predictions. Astronomers use gravitational lensing to spot these mysterious invisible structures, suspecting they're vast clusters of dark matter, an elusive cosmic component making up over a quarter of our universe, yet remaining entirely invisible. It's the universe's greatest magic trick, dark matter pulling strings from behind the curtain, shaping galaxies, guiding cosmic evolution, yet evading all direct detection. Finally, we journey to one of the greatest mysteries, the axis of evil. Yes, you heard right. Cosmologists humorously dubbed this anomaly due to its troubling implications. The cosmic microwave background, the echo from the birth of the universe itself, unexpectedly aligns itself along a specific cosmic axis. It hints that the universe may have a preferred direction, which would shake the very core of cosmology, challenging our assumption that the cosmos is isotropic, equal in all directions. Is this cosmic alignment mere coincidence, or a hint that reality itself is structured in ways we've yet to fathom? These anomalies, these cosmic oddities, force us to reconsider everything. They're reminders that despite our impressive technological achievements, despite our intricate equations and theories, we remain humble explorers, sailing into unknown waters beneath a sky filled with mysteries yet to be solved. Out there, beyond the comfort of our daily lives and our tidy explanations, lies an ocean of mysteries, waiting patiently for our attention. Consider neutron stars, stellar corpses so dense that a mere teaspoonful of their material weighs as much as a mountain. But among these strange celestial bodies are pulsars spinning hundreds of times per second, flashing beams of radiation like cosmic lighthouses guiding us through the unknown. Imagine it, a star-sized object rotating faster than a kitchen blender. Physics stretched to breaking point, yet somehow holding steady. Journey further into strangeness, and you'll encounter magnetars, neutron stars on steroids. These stellar giants boast magnetic fields billions of times stronger than Earth's, powerful enough to strip atoms apart from thousands of kilometers away. Even from halfway across the galaxy, a magnetar's sudden eruption can blast Earth with X-rays intense enough to briefly disrupt our satellite communications. Think about it. Cosmic tantrums capable of affecting our modern technological world, despite originating thousands of light years away. If neutron stars seem extreme, try this cosmic oddity on for size: quark stars. Hypothetical objects so dense, neutrons themselves disintegrate under extreme pressures, giving rise to a sea of quarks, the fundamental particles making up all matter. It's as though nature tears down its own rules, allowing bizarre forms of matter to exist right under our cosmic noses. Though purely theoretical, quark stars could redefine our entire understanding of stellar evolution, potentially hiding in plain sight within neutron star disguises. But let's not neglect the phenomenon of gravitational waves, ripples in space-time itself. Einstein predicted them, but it took humanity nearly a century to directly detect these elusive distortions. Generated by cataclysmic cosmic events, like the merging of black holes billions of years ago, these waves ripple across billions of miles, quietly whispering the universe's most dramatic secrets. Every gravitational wave detected carries stories from the farthest corners of reality, allowing us to hear cosmic symphonies otherwise invisible and silent to traditional telescopes. Now consider the phenomenon known as dark flow, a mysterious observation indicating galaxy clusters moving toward an unknown gravitational attractor lurking far beyond the observable universe. Imagine entire groups of galaxies, billions of stars strong, drifting like leaves caught in a hidden cosmic current. Could there be massive structures beyond our horizon influencing the observable universe? Or is this phenomenon a hint of hidden dimensions, pulling strings from just beyond our cosmic sightline? Speaking of dimensions, let's dive even deeper into the unknown, parallel universes. Some scientists speculate that every decision we make, every quantum fluctuation, creates branching universes, a multiverse sprawling infinitely in all directions. Sounds like science fiction? Perhaps. Yet quantum mechanics and cosmology continually dance on this edge, flirting with realities far stranger than fiction itself. Imagine infinite versions of you, each living a slightly different life, scattered across countless parallel universes. Science boldly stepping where imagination once exclusively roamed. And if infinite worlds weren't enough to ponder, there's the baffling quantum entanglement, Einstein's famous spooky action at a distance. Picture two particles linked instantly, regardless of the distance separating them, communicating faster than the speed of light. Quantum entanglement teases a reality where space and distance become illusions, challenging our intuitive understanding of the universe, whispering softly to physicists that reality may not be what it seems at all. Our cosmos doesn't just hold secrets, it actively beckons us, inviting us deeper into realms that defy comprehension, forcing us to ask profound questions about existence itself. With every discovery, we're reminded that science isn't simply about finding answers, but about discovering better, more intriguing questions that lead us ever further toward the very edge of reality. This is Whispers of the Cosmos. We look up at the stars and see beauty, order, a cosmic dance of planets, galaxies, and light. But behind that serene facade lurk ideas so terrifying, so mind-bending, that they shake the foundations of everything we think we know. The universe isn't just vast, it's stranger, darker, and far more unsettling than we dare to imagine. Take the idea of heat death. One day, the universe might not end in fire, but in silence, a slow, freezing fade out into nothingness. As stars burn out and galaxies drift apart, energy will spread thinner and thinner until there's no usable heat left, no motion, no life. Just a cold, empty void stretching forever. It's not a dramatic finale, it's a quiet, endless darkness where even time loses its meaning. But maybe we won't even make it that far. Vacuum decay could erase us long before the stars flicker out. If the universe exists in a false vacuum, a temporary unstable state, a tiny bubble of true vacuum could appear anywhere, at any moment. Expanding at the speed of light, it would annihilate everything it touches, rewriting the laws of physics in an instant. No warning, no escape, no trace. Reality as we know it, gone before you even realize it happened. And what about Boltzmann brains? According to some interpretations of thermodynamics, it's statistically more likely for a fully formed, conscious brain with false memories and perceptions to spontaneously pop into existence in the void than for the entire universe to form as we observe it. In other words, you might not be real. you could just be a fleeting thought in a sea of chaos, destined to blink out of existence as quickly as you appeared. Then there's the nightmarish concept of the Big Rip. As dark energy accelerates the expansion of the universe, it could eventually tear apart galaxies, then stars, then planets, and finally, the very atoms themselves. First, the night sky would empty. Then, solar systems would unravel. Finally, as the end approached, even the molecules of your body would be shredded by a force no shield could withstand, a cosmic unraveling, atom by atom at the speed of inevitability. But maybe it's worse than that. Maybe the universe is cyclic, endlessly repeating itself. Big bangs followed by big crunches, rebirths followed by destruction, over and over for all eternity. Every life you live, every memory, every moment of joy or despair, doomed to repeat endlessly, trapped in an infinite loop you can never break. Freedom, choice, meaning, illusions, forever reset at the closing of each cosmic cycle. And then there's the bleak suggestion that we might be living inside a simulation. Maybe none of this is real. Maybe some ancient godlike civilization created our universe as a playground, a science experiment, or a forgotten relic of their history. Everything you've ever loved, every triumph, every sorrow, mere lines of code running in a cosmic computer you'll never see, operated by beings you'll never understand. Even more unsettling is the idea that the universe is hostile by design. Maybe intelligence is doomed by the very laws of nature. Maybe the conditions for life are so rare, so fragile, that civilizations everywhere flicker out before they can reach the stars, snuffed out by their own technology, cosmic disasters, or simply the cold indifference of a universe that doesn't care. And what if the darkness we see between galaxies isn't empty at all? Some theories suggest the existence of dark flow, a mysterious, massive movement of galaxy clusters towards an unseen, unknown region of space. Something out there might be pulling at our universe with gravitational fingers we can't detect or comprehend. A force older than the Big Bang, lurking beyond the edge of everything we know. Then there's the idea that the universe has no bottom, that no matter how deep you go, there's always another level of structure, another layer of reality. Quarks, strings, quantum foam. What if there's no end to the rabbit hole? What if we are forever trapped in an infinite descent into smaller and smaller scales, with no hope of ever reaching bedrock? A universe of endless mystery, forever just out of reach. And finally, the ultimate terror. We are completely alone. No ancient civilizations sending signals, no distant worlds brimming with alien life. Just one tiny planet, orbiting an average star, in a forgotten corner of an ordinary galaxy, utterly isolated in an unimaginably vast emptiness. If that's true, then the universe isn't just indifferent to our existence. It's silent, and we are the only witnesses to its infinite beauty, its infinite indifference. The universe is not just a place of wonder. It is a place of profound, almost unbearable strangeness. And every time we peel back a layer, we find not comfort, but deeper mystery, staring back at us through the abyss. And as if the terror of existential isolation weren't enough, some scientists propose the idea of a multiverse, a limitless sea of universes, each with different laws of physics, different constants, different fates. In one, gravity might be too weak for stars to form. In another, atoms might not even exist. And if infinite universes truly exist, then there are infinite versions of you. Some living wildly different lives, others perishing in worlds too hostile for anything recognizable. every choice, every chance, every horror played out somewhere across the endless tapestry of existence. But not all multiverses are gentle. Bubble universes could be expanding within this cosmic foam, and if one of these bubbles, governed by different physical laws, collided with ours, the result would be catastrophic. Like a cosmic tsunami, its frontier would obliterate everything in its path at nearly the speed of light, rewriting the very foundations of reality as it passes. No warning, no defense, just a wall of unstoppable change rolling across the heavens. Another unsettling idea: the observable universe is just the smallest sliver of the true cosmos. What we can see, all the galaxies, stars, and nebulae, could be just a tiny island in an infinite ocean. Beyond our visible horizon, endless realms may stretch on forever, utterly unreachable, forever hidden from us by the limits of light and time. And out there, the laws of physics might not just be different. They might be lethal to anything like us. And then there's the terrifying possibility of cosmic string catastrophes. These hypothetical defects in space-time, thinner than an atom, yet heavier than a mountain range, could whip through the cosmos at near-light speeds. If one passed through our solar system, it could slice planets in half like a cosmic scalpel. Earth, in the blink of an eye, could be split into two incandescent halves, reduced to molten debris spiraling into the void. Another mind-bending theory warns of time being an illusion, that our sense of past, present, and future is a trick of consciousness. In reality, all moments might exist simultaneously, stacked like pages in a book. You aren't moving through time. You are simply experiencing one page at a time. Your birth, your death, the death of the stars, all already written, immutable, unavoidable. And if you think black holes are terrifying simply because they devour everything in their path, brace yourself for the idea of black hole cosmology. Some theorists suggest that every black hole might spawn an entirely new universe inside it. That means inside each black hole's event horizon, untold billions of new cosmoses might be unfolding, completely cut off from our own, each one birthing stars, galaxies, maybe even life. And if that's true, our own universe might be the inside of some other cosmic black hole, born in the violent death of a parent universe we will never know. And while we're talking about dark ideas, we can't ignore phantom energy, an even more aggressive form of dark energy that doesn't just accelerate the expansion of the universe. It accelerates it faster and faster over time. In such a scenario, galaxies would be torn apart, stars shredded, planets ripped to atoms, and even the very fabric of space itself would be pulled apart. Space wouldn't just expand, it would stretch until it shattered. The chilling reality is that most of the universe is invisible to us. Dark matter and dark energy, two of the greatest mysteries in modern physics, make up over 95% of everything, yet we cannot see them, touch them, or fully understand them. We are shadows, living in the glow of an invisible, dominant cosmos. Whatever dark matter is, it's all around us, passing through us, woven into the very architecture of existence. And we don't even know if it's benign. And if that doesn't rattle your sense of security, consider the idea that causality itself could break down. In some extreme gravitational environments, like near the heart of spinning black holes, the normal flow of cause and effect could collapse. Events might happen out of order. Effects could precede causes. Reality itself could become a hall of mirrors where logic, reason, and sequence are abandoned. A cosmic madhouse where nothing you rely on to understand the world would hold true. The deeper we gaze into the abyss of the cosmos, the clearer it becomes. The universe is not here to comfort us. It is vast, it is indifferent, and it harbors secrets far more terrifying than any nightmare the human mind can conjure. Yet still, we reach outward, daring to ask questions whose answers might forever change how we see ourselves and everything around us. And just when you think you've wrapped your mind around these terrifying ideas, the universe pulls back another curtain. Some physicists propose the unsettling notion of quantum immortality. According to certain interpretations of quantum mechanics, every time a potentially fatal event happens, the universe splits. In one branch, you perish, but in another, you survive. From your own perspective, you never die. You keep waking up in a world where you somehow escaped fate, no matter how improbable. But the cost? Endless universes where countless versions of you meet countless inevitable ends. A multiverse cemetery sprawling beyond comprehension. Another chilling speculation is the idea of information loss in black holes. If true, it means that when something falls into a black hole, not just its atoms, but its information, the very blueprint of its existence, is erased from the universe. This breaks one of the fundamental laws of physics, that information must be conserved. If black holes really do destroy information, then the universe itself becomes a place where history can be erased, memories lost, and meaning itself swallowed forever by the darkness. And lurking even deeper in the speculative shadows is the concept of the ultimate fate of intelligence. Some theorists believe that no matter how advanced a civilization becomes, it's doomed by the very structure of the cosmos. Entropy will always win. Stars will burn out. Energy supplies will dwindle. Eventually, even the most brilliant minds, the most resilient machines, the most enduring ideas will be snuffed out by the slow, creeping death of the universe itself. There's even a possibility that time might spontaneously reverse. Deep within the chaotic interplay of thermodynamics and quantum fluctuations, there could come a moment when the arrow of time flips, running backward. Cause would follow effect. Stars would unform. Civilizations would crumble into dust, and then the dust itself would reassemble into ancient worlds. It would be a cosmic rewind so alien, so profound, that existence as we know it would become a surreal, broken mirror of itself. Or consider the idea of false memories. The chilling thought that the universe could be so old, so vast, that entire civilizations might be engineered into existence with fabricated memories. You could have been born 5 minutes ago, implanted with every recollection, every scar, every dream, all of it illusions stitched into your mind by the random, merciless chaos of an infinite cosmos. And one of the ultimate cosmic horrors? Existence might not require consciousness at all. In the grand scheme, thinking beings could be a fluke, a temporary, unnecessary glitch in an otherwise mindless, mechanical unfolding of matter and energy. Intelligence, creativity, wonder, mere sparks against the dark, soon extinguished and forgotten by a universe that neither notices nor cares. The more we learn, the more we realize the universe isn't built for comfort. It isn't crafted for survival. It isn't tailored to our hopes, our dreams, or our desperate need for meaning. It simply is a cold, vast, indifferent reality where beauty and terror are inseparably intertwined. Every star that shines is a star destined to die. Every planet that forms is one meteor away from obliteration. Every life that blooms carries within it the seeds of its inevitable end. And yet, we explore, we question, we reach out into the dark. Here, at Whispers of the Cosmos, we lean into that darkness. We listen to the chilling secrets that the stars refuse to shout, but whisper instead. Quiet truths, woven into the fabric of existence. Every terrifying theory, every unimaginable mystery, every cosmic revelation reminds us that we are part of something far bigger, far stranger, and far more breathtaking than we ever dared believe. So we will keep asking, keep seeking, and keep listening to the universe, one whisper at a time. When you think about speed, maybe you imagine a race car, a fighter jet, or even a rocket ripping through Earth's atmosphere. But out there, beyond our tiny blue planet, the cosmos has a whole different idea of speed, a level so extreme it shatters the imagination. Today, we dive headfirst into the most bizarre objects spinning at speeds that make the wildest roller coaster seem like a lazy Sunday drive. Imagine an object no bigger than a city, spinning so fast that if you stood on its surface, you'd be launched into space faster than you could blink. That's the reality of a neutron star, the crushed corpse of a once massive star. When a star dies in a supernova explosion, if the conditions are just right, its core collapses into a sphere so dense it defies our understanding of matter. Some neutron stars, known as millisecond pulsars, rotate hundreds of times per second, 700, even 800 revolutions every tick of the clock. That's faster than the blades of a helicopter, faster than a bullet speeding from a gun. The forces at play are so fierce that the star's crust, an iron shell thicker than Mount Everest is tall, literally cracks and quakes under the strain. But if you think that's crazy, buckle up. There's a particular pulsar out there named PSRJ 1748-2446 AD, the fastest spinning neutron star ever discovered. It rotates at an insane 716 times per second. That's nearly a quarter the speed of light at its equator. If it spun just a little faster, it would tear itself apart. Nature, it seems, loves to live on the edge. And what about white dwarfs? These smoldering, planetary-sized remnants of dead stars are usually calm. But not always. Some white dwarfs spin at blistering speeds, completing a full rotation every few minutes. That's like an object the size of Earth spinning so fast that an entire day lasts less than the time it takes to heat your coffee. These compact beasts maintain incredible rotational energy, trapped in a silent, frozen ballet that's been dancing for billions of years. Now zoom out even further, beyond stars, beyond planets, to the chaotic hearts of galaxies. Supermassive black holes, monsters millions or even billions of times the mass of our sun, don't just sit there quietly. Some of them spin at near light speed. Picture a singularity, a point of infinite density, wrapped in a whirling maelstrom of space-time itself. At these speeds, the very structure of reality bends around the black hole, twisting magnetic fields, warping space, dragging entire star systems into violent, incandescent orbits. The most extreme among them spin so fast that if you were unlucky enough to fall in, you wouldn't just be swallowed, you'd be twisted and mangled across dimensions as you disappeared into oblivion. But not everything spinning insanely fast has to be massive. In the cosmic junkyard of the solar system, tiny asteroids are doing pirouettes faster than any Olympic figure skater. Some, like asteroid 2008 HJ, rotate completely in under 30 seconds. Imagine a rock hurtling through space, barely 12 meters wide, yet spinning so fast that its surface speeds exceed hundreds of kilometers per hour. If it were made of anything less dense than solid rock, it would disintegrate into a cloud of dust. It's a cosmic tightrope act, with gravity and momentum locked in a perpetual daredevil's handshake. And then there are stars like VFTS 102, a massive blue giant tearing through its rotation at over 2 million kilometers per hour at its equator. That's so fast, its entire structure bulges outward, stretched into an oblate spheroid by centrifugal forces. This is a star, barely holding itself together, living every second on the razor's edge, between cohesion and collapse. It's not just burning hydrogen, it's burning through the limits of physics itself. Finally, let's talk about something you wouldn't expect to make the list: planets. Take Jupiter, for example. Despite its titanic size, a planet so large it could fit over 1,300 Earths inside, Jupiter spins faster than any other planet in the solar system. A single day on Jupiter lasts just about 10 Earth hours. That's like spinning a skyscraper-sized ball of gas and storms at breakneck speed without it flying apart. And it's no gentle whirl either. This rapid rotation powers Jupiter's monstrous storms. Storms so big they could swallow Earth whole, fueled by a spin that just won't quit. In the grand theater of the universe, speed is a currency, and the cosmos spends it with reckless abandon. In neutron stars whirling like cosmic blenders, in asteroids dancing at the edge of destruction, in black holes that twirl space-time into knots. Speed isn't just about motion. It's about the violence, the power, and the sheer unstoppable momentum written into the DNA of the universe itself. But the universe doesn't stop at spinning stars, collapsing cores, and rampaging asteroids. It gets even stranger. It gets wilder. Some objects aren't just spinning fast, they're spinning in ways that defy every rulebook we thought we understood. Take spinning quark stars, theoretical objects even denser than neutron stars. If they exist, they could spin even faster, their surfaces moving at a terrifying fraction of light speed. Inside, the very matter is crushed beyond atoms, into a soup of quarks, the building blocks of protons and neutrons. Imagine an object no bigger than a city, spinning so viciously that space-time itself ripples around it like water around a whirlpool. It's a cosmic blender operating at speeds and densities where physics itself begins to lose meaning. Or picture the fastest spinning brown dwarfs, objects too big to be planets, too small to ignite as stars. Some of these cosmic misfits complete a rotation in just a few hours. They spin so fast that their equators bulge outward, like cosmic belly dancers, puffed up by centrifugal force, defying the smooth, serene faces we associate with stars and planets. These are failed stars partying like it's the end of the universe, flaunting their speed for all of creation to see. Even closer to home, Earth isn't immune to bizarre spin phenomena. Our planet doesn't rotate at a perfectly constant rate. Tiny changes, gravitational tugs from the moon, mass movements of the atmosphere and oceans, cause Earth's spin to wobble, to speed up, to slow down. Earth is engaged in a slow cosmic dance, its spin subtly swaying with the invisible currents of the solar system. It's a reminder that even something as familiar as one day is really a delicate balancing act on a cosmic stage. Then, there are entire galaxies that spin like titanic pinwheels in the night. Take the Cartwheel Galaxy, whose perfect, eerie shape was sculpted by a collision with another galaxy millions of years ago. Its outer ring is spinning outward, pushing through space like a shockwave frozen in time. Entire solar systems are riding that wave, hurled forward by the echoes of a galactic impact, moving through space at speeds beyond imagination. Or consider ultra-fast magnetars, neutron stars born not just spinning fast, but magnetized to the extreme. Their magnetic fields are so powerful, they can slow their insane spin down dramatically within just a few thousand years, blasting energy into the cosmos like galactic lighthouses gone berserk. At birth, they spin so fast, perhaps over 1,000 times per second, that the energy released could outshine an entire galaxy for brief, searing moments. These are cosmic firecrackers, burning bright and dying young, leaving behind ghostly remnants whispering through the void. And while we're at it, let's not forget the accretion disks around young stars. These spinning maelstroms of gas and dust aren't just picturesque. They're high-energy factories where new planets are forged. These disks rotate at staggering speeds, with material moving faster than the speed of sound in gas. Every inch of these swirling disks is a chaotic battle of gravity, pressure, and turbulence, a frantic, furious dance where worlds are born in violence. The universe doesn't just spin, it pirouettes, it whirls, it howls through the endless night with energies and speeds that stretch the very fabric of space and time. Every spinning object out there, from tiny asteroids to monstrous black holes, is a reminder that motion is life, motion is violence, and motion is the heartbeat of the cosmos. The stars don't just burn, the planets don't just orbit, the galaxies don't just drift. They spin, they rage, they scream across the silent emptiness at speeds that mock our puny human understanding of motion. And just when you think the cosmic carousel couldn't spin any faster, quantum mechanics steps into the arena and completely rewrites the rules. At the smallest scales imaginable, particles like electrons and quarks exhibit a strange property called intrinsic spin. Not spin like a planet or a top, but an inborn angular momentum that defies everyday intuition. These fundamental particles are spinning metaphorically at impossible speeds, forever locked into a quantum twirl that underpins the very structure of reality. Without this ceaseless, invisible motion, atoms wouldn't hold together, chemistry wouldn't work, life itself wouldn't exist. Even entire clusters of galaxies, unimaginably vast collections of hundreds, even thousands of galaxies, have been caught in the act of rotating slowly over billions of years. Their spins are so colossal, so ancient, that they trace back to the earliest whispers of structure in the universe, seeded in the aftermath of the Big Bang. It's a cosmic inheritance of motion, a momentum handed down through eons, echoing across the darkness. Some theorists even speculate about exotic objects called Gravis stars or boson stars, hypothetical entities that might spin in ways even more exotic than anything we've ever observed, combining extreme mass, rapid rotation, and quantum properties into a cocktail that pushes the very limits of known physics. If these objects exist, they could be the most bizarre and fastest spinning phenomena in all of creation, hidden out there, waiting for our instruments to catch up to their mystery. Rotation is the language of the universe's most extreme and most delicate creations alike, from collapsing giants to newborn stars, from tumbling asteroids to the quantum pirouettes of invisible particles. Spin is a fundamental, inescapable feature of existence. It powers magnetic fields that protect worlds. It sculpts solar systems. It unleashes jets of energy that stretch across millions of light years. In the end, spinning is not just what objects in space do. It's what space itself does. Every whirl, and every twirl is a frozen signature of past violence, past creation, past change. The cosmos remembers its history in every turn, every rotation, every impossible spin we glimpse through our telescopes and instruments. It's a universe that never stands still, a universe forever in motion, forever alive. Here at Whispers of the Cosmos, we chase those secret motions, those hidden rotations, those cosmic pirouettes that define the very fabric of existence. Every spin, every pulse, every orbit is a whisper carried across the void, a message from the universe itself. And as long as there are mysteries whirling in the darkness, we'll be here, listening, exploring, and sharing their stories with you. One cosmic whisper at a time. Imagine setting out on a cosmic journey, fueled by wonder, curiosity, and just a hint of madness. The universe is vast and beautiful, but it's also a place of unimaginable dangers. If you think a shark-filled ocean is terrifying, just wait until you see what the cosmos has cooked up. So buckle up, traveler. Today, we venture into the top 5 most dangerous places in the universe to visit. First stop, the surface of a neutron star. Picture this, a city-sized sphere, packing more mass than our entire sun, crushing atoms until they become an ocean of neutrons. Step foot here, if that were even possible, and you'd be flattened instantly by gravity 2 billion times stronger than Earth's. Forget hiking boots, you'd need quantum armor, just to survive the first nanosecond. Time, space, and even the definition of matter itself twists under such pressure. Here, reality bends, and the line between science and science fiction blurs. Next, we drift toward the center of a supermassive black hole. It sounds poetic, spiraling into a cosmic ballet of darkness, but in truth, it's pure annihilation. As you approach, tidal forces stretch you thinner and thinner until you become a single strand of atoms, a phenomenon chillingly named spaghettification. No spaceship, no shield, no desperate scream can save you. You wouldn't even see it coming. The very light carrying the warning signs is swallowed whole, lost to eternity. Crossing the event horizon is a one-way ticket, and no postcards from the other side. Now, let's get adventurous. How about visiting the Buddha's Void? Sounds harmless, right? Wrong. Imagine a region of space so empty, so utterly devoid of stars, galaxies, and light that it stretches nearly 330 million light-years across, like a cosmic ghost town. Travel here, and you'd find yourself in a cosmic silence so deep, your mind might fracture under the sheer psychological weight. No light, no stars, no beacons to guide you home. Just endless, suffocating darkness, whispering into the folds of your sanity. Feeling brave? Good, because now we're heading to the gamma-ray burst zone. Somewhere out there, massive stars are dying in violent explosions, releasing more energy in a few seconds than our sun will produce over its entire 10 billion-year lifetime. If you happen to be anywhere nearby, and by nearby, I mean hundreds of light-years away, the radiation would incinerate your spacecraft, strip away your atmosphere, and cook your DNA like overdone bacon. You wouldn't even have time to register the flash. You'd simply cease to exist, erased by a silent cosmic bullet traveling at the speed of light. And finally, the crown jewel of cosmic nightmares, the quasar's heart. Imagine a black hole so ravenous that, as it devours entire stars, it spews jets of radiation millions of light-years into space. A quasar's core shines brighter than entire galaxies combined, but approach too close, and you're caught in a maelstrom of lethal particles and magnetic storms. Here, physics goes feral. Gravity becomes a tyrant. Light itself struggles to escape the chaos. Visiting a quasar's core would be like flying into the mouth of an angry god, a blinding fury of energy, soundless but merciless. The universe is breathtaking, yes, but it is also merciless in its indifference. Beauty and terror, intertwined like twin strands of DNA, stitched into the very fabric of existence. And while we gaze up in awe, safely tucked away on our pale blue dot, these cosmic monsters lie in wait, silent, patient, eternal. But danger in the universe isn't always about brute force or cosmic violence. Sometimes it's about environments so alien, so extreme, that they defy the very rules life depends on. Take the atmosphere of a hot Jupiter, giant exoplanets that orbit scorchingly close to their stars. Here, temperatures soar to thousands of degrees, and winds scream at speeds of over 5,000 miles per hour. Iron doesn't just melt, it vaporizes, forming metallic clouds that rain molten droplets from the skies. Imagine standing on a world where the storm clouds aren't water, they're boiling metals, and every breath would ignite your lungs. Even machines wouldn't survive more than a few seconds in that hellish cauldron. Or consider the core of a white dwarf, the smoldering skeleton of a dead star. If you could somehow dig down into this cosmic ember, you'd find something truly bizarre. A mass of crystallized carbon and oxygen, essentially